In this video, we are learning about trigonometric ratios. Specifically in this lesson, we are going to be focusing on the sine ratio. So there are three trigonometric ratios. Each trig ratio is a fraction made up of two specific sides of a given right triangle. Now that's based on which angle is being used. So the three trig ratios are sine, cosine, and tangent. So each one of these represents a ratio or a fraction made up of two of the sides based on which angle is being used. So sine is abbreviated SIN in the calculator, and it's always the sine of whichever angle is being used. So sometimes you'll see this Greek letter theta, which denotes some angle measure. So the sine of any angle measure that's given is always the opposite side over the hypotenuse. That's what we're going to be focusing on today, but I do want to go ahead and introduce you to the other two ratios. For cosine, that one is abbreviated COS in the calculator, so the cosine of whichever angle is given is always the adjacent over the hypotenuse. And finally, tangent is abbreviated TAN, so the tangent of whichever angle is given is always the opposite over the adjacent. Today we are going to be focusing on sine only. So let's look at this triangle that's given here, and let's find the sine of angle X. So the sine of angle X, we're going to make sure that we're looking from angle X to start out. We're going to write down the fraction, which is the opposite side over the hypotenuse. Now remember, the hypotenuse is always directly across from the right angle. So our hypotenuse is always going to be C for this specific triangle. Right, so our trig ratio for the sine of angle X is B over C, because that's the opposite side from angle X over the hypotenuse of this triangle. Now let's find the sine of angle Y. So if I'm using Y as my angle of reference, I'm going to look at the opposite, which is A, over the hypotenuse, which is C. So whatever those actual numeric values are, you're just going to plug those into your calculator and divide. So now let's look at some actual examples with some numbers. I'm going to open up Desmos. And before we even get started with anything, I want you to click in Desmos, that little tool button, which is your settings, and make sure that you have degrees selected instead of radians. Now for number one, it just says to evaluate the value of sine using a calculator. So we've already made sure that we are in degree mode, and to find the sine of this angle that's given, 38, there are two things we can do. You can type in SIN using the keyboard and then put parentheses with 38 inside. Or you can go to Functions, Trig, Sine, and then type in 38 in the parentheses. Okay, we are going to be rounding to the nearest tenth just to keep things simple. So the sine of 38 is simply 0.6. Okay, now in number two, we have to calculate the sine based on this triangle by setting up our trig ratio. So if we're going to find the sine of angle C, first we have to make sure that we're looking from angle C, and we need to set up the opposite over the hypotenuse. So remember, the hypotenuse is going to be directly across from the right angle. So now we can set up that sine C is the opposite, which is 28, over the hypotenuse, which is 35. So in our calculator, we're going to type in 28 over or divided by 35, and we get 0.8. And that's it. Number 3, the sine of angle A. So we're going to look from angle A and see that directly across is 32. So that's the opposite. And the hypotenuse is directly across from the right angle, which is 40. So 32 divided by 40 is also 0.8. Number 4 must have gotten pushed to the next page. Oops. Yeah, there we go. Let's see. This is actually number 4. All right. The sine of angle Z. So if we're looking from the angle Z here, directly across is going to be the opposite. That's 24. And the hypotenuse, which is directly across from the right angle, is 40. So 24 divided by 40 is our sine here. And that is 0.6. Number 5. Now we are using a sine, that whole ratio and that whole equation, to find a missing side value. So now we aren't given the angle to look from and 2 of the sides. We're just given the angle to look from and 1 of the sides. So we have the angle 51. We have the opposite side, and we have the hypotenuse. So even though we aren't even if we weren't told to use sine, we would know that we have to because we have the opposite and the hypotenuse. So anytime you have the opposite and the hypotenuse information, that means you're going to set up the sine of that angle. Okay, I typically write it the other way. So I'm going to write, to start solving, sine of 51 equals the opposite, which is 14, over the hypotenuse, which is x. So here, we're actually trying to find the hypotenuse length. Now to do that, all we have to do is solve this equation, just like you would solve any equation. You're going to treat sine of 51 just like it's a regular number. So if we want to get x by itself, we first have to get it out of the denominator of this fraction. So we are going to multiply by x on both sides. And when we do that, the x on the right side being multiplied and divided cancels one another out. So we have x times sine of 51 equals 14. Okay, so the division by x and the times x cross each other out. All right, now we want to continue getting x by itself, so we need to undo this times sine 51 by doing division by sine of 51. So we're treating that just like it's a regular number. So we're going to divide by sine of 51 on each side. Okay, now sine of 51 over sine of 51 is 1, so that cancels each other out. And we're left with just x equals. Now we can evaluate. So we're looking for 14 divided by sine of 51. So we got 18.01. We're going to round to the nearest tenth, so that would just be 18.0. Right, now as you're going through these, another thing to keep in mind is that the hypotenuse has to be the longest side because it's the longest side of the triangle. So if this is 18.0, that's definitely longer than 14, so we're good. We don't necessarily know what that third side is, but as long as it looks like we are having a hypotenuse that's the longest side, then that's just another way to check yourself. Okay, number 6. This one is also, we're looking for the hypotenuse. In this one, we are going to set up sine. So we have the angle 63, so that's going to be sine of 63 equals the opposite over the hypotenuse. Okay, so again, we want to solve for x, so we're going to do times x on each side. That leaves us with x times the sine of 63 equals 16 because the x's cancel each other out. Oops. All right, and that leaves us with the last step is to divide by sine of 63. All right, now we have sine 63 over sine 63, that's equal to 1. So we have x equals 16 over sine of 63. And we're going to evaluate that. That gives us 17.95. Okay, so we have x is 17.95. Okay, we're rounding to the nearest tenth, so that 5 would bump the 9 up to a 10, which would then bump 17 up to 18.0. Okay, so again, that hypotenuse is longer. 18 is longer than 16, so that leaves us in a good spot. And finally, with number 7, use the sine ratio to find side x. Even if we weren't told to use the sine ratio, we have our angle here, we have the opposite side, and we have the hypotenuse. So sine of the angle 15 is the opposite over the hypotenuse, so 16 over x. That same process is going to happen here. So we're going to do times x on both sides. They'll cancel on the right. So x times sine of 15 equals 16. And we're going to divide by sine of 15 on each side. Okay, sine 15 over sine 15 is equal to 1, so that can be crossed out. So x is 16 over sine of 15, and we need to evaluate that amount. So 16 divided by sine 15. That gives us 61.81.